Hey everybody, coming to you live with Experiment 1 Fischer Esterification. This will be a 3-minute video, real fast, check it out. Basically, Fischer Esterification is a reaction that takes a carboxylic acid and a alcohol. So this is your p-aminobenzoic acid, this is your ethanol. It happens in the presence of an acid catalyst such as sulfuric acid, which we use in this experiment. We use sulfuric acid to make a ester. So what happens here is the OH group of the carboxylic acid and the H group of the alcohol combine together to form H2O, which leaves. That classifies this as a condensation reaction. Water is being removed, and this is now just going to be attached to the carboxyl carbon of the p-aminobenzoic acid to form the ester, which this is the ester, right? The C double bond O, O, R. Here's the R group. Here's another O. And water here. So that is benzocaine, which was our product, which is like a subset of kind of like cocaine. So don't do drugs. Don't do drugs, let me tell you. All right, next. What did we add and why? This will be really fast, but hopefully cover everything. P-aminobenzoic acid, which is a carboxylic acid, and ethanol, added with the acid catalyst concentrated sulfuric acid, H2SO4. The H2SO4 was used to catalyze or start the reaction. It's a catalyst. Sulfuric acid is a catalyst. It supplies a hydrogen atom, and we can see that here. We have our carboxylic acid main reactant. Reactant. Then we have our sulfuric acid here, and this gets deprotonated, and this gets protonated. So it supplies a hydrogen atom to start the reaction. Once that occurs, we can see our alcohol, ethanol, will come in as a nucleophile, attack, and be added on to this. So basically, H2SO4 is the catalyst. Supplies a hydrogen, starts the reaction. Ethanol acts as a nucleophile. It does nucleophilic attack, addition of a nucleophile. So ethanol comes in, attacks, and it is added on down here. Ethanol is added here, and then we have some deprotonation. The water leaves, forming a leaving group, blah, blah, blah. Okay, so somewhere down the road after we get our product made, right, we have it in a flask now. We need to raise the pH. We have concentrated sulfuric acid still in it. It's a low pH, it's acidic. So we're gonna add sodium carbonate, Na2CO3. This is to neutralize the solution. Basically, this brings the pH up to 8 is what we're looking for. We're converting the H2SO4 that carried over into the flask to a salt. So we're removing sulfuric acid, H2SO4. I know this is blurry. All right, here's the equation. Na2CO3 plus H2SO4. So the sodium carbonate plus the sulfuric acid gives a sodium sulfate, which is a salt, Na2SO4, which is actually our drying agent that we use a lot, anhydrous sodium sulfate, plus water, right? Plus CO2. So we can see where the water is coming from, H2O, plus CO2, which is a gas, which is why it will froth. Frothing occurs, bubbling occurs. As frothing is finishing, pH should be around 8. White precipitate of benzocaine, the product is produced. So CO2 will form, effervescence will occur, frothing, bubbling. Then finally, we have our crude product, we weighed it, whatever. But now we want to purify it farther, so we added methanol, which is a solvent, to the crude product. So benzocaine is a product. It is highly soluble in methanol or ethanol or any kind of alcohol. So that's how we use methanol. We dissolve the solid benzocaine product. Then we can use this. It's called a mixed solvent method. So we actually put the benzocaine in water and methanol, or added methanol to that. And basically when it dissolves, then we cooled it off, recrystallized it. It's another purification technique, and basically purified it, and we have our final product. So that is all we did. Next video, we'll work some questions maybe. I'm out.